Hello, my name is Darren Thomas. I am the Director of Educational Research Techniques. In this video, we're going to take a look at solving quadratic equations with the square root property. So let's go ahead and get started. Now, when we're talking about solving quadratic equations with the square root property, we're only talking about quadratic functions or quadratic equations that take the following characteristic, ax squared, where a is the constant, and then of course x is your variable, and it's raised to the second power. So we're only talking about that limited sense. We will deal with other types of quadratic equations later. So having said that, let me go ahead and show you how this can be done with the square root property. And of course, we know what the square root property is, and that it involves dealing with the radical and the radicands and all those things like that. So to give you a basic example of the square root property, let's say you have x squared equals 36. You would obviously subtract 36 from both sides, get x squared minus 36 equals 0. And then, of course, now you can split this. And what we mean by square root, basically is like, a square. And how can we make both these sides the same? And, of course, it'd be x, let's see here, x minus 6, x plus 6, like so. And then that would be able to give you the 0. So x could equal plus or minus 6, like so. So our square would have to be 6 by 6, in other words. That's what we're getting here. This is the square root property in action. And so having said that, I want to now show you how this will work in a practical sense when we're trying to solve a quadratic function. So imagine we have the following values here. We have x squared minus 48, and of course it equals 0. Now, the first thing you want to do, and this is just basic algebra, is you just want to add 48 to both sides because you're trying to isolate, oh, I forgot the equal sign. You're trying to isolate the x squared. And so now you have x squared equals 48. But we're still not quite done yet. And so the next thing we do is we want to square root both sides, if you will. So just kind of do something like this. And so I'm left with x equals the square root of 48. And now I need to factor the 48. In other words, what can I do? And what I'm doing for this, I'm looking also for perfect squares, because then that'll give me real numbers or whole numbers that I can, put on the outside of the radical. So when I factor the 48, I just get the following. To make it nice and simple, I would get the square root of 16 times the square root of 3. And of course, all this equals x. Let me make this nice and clear. And so you should already know that the square root of 16 is 4. So let me go ahead and give you the final answer here. So the final answer would be 4 times the square root of 3. This is what x equals, like so. And you can see that right there. And you can check this at home to see if this works. But this is our answer as shown here, because when you square root 16, it gets 4. You get the answer of 4. All right, so we have 2 more examples to go here. Let's do something a little bit different, and I'll show you how it works in this particular context. So this time we have 2x squared equals 98. So what do we do in this situation? Well, again, our goal is to isolate the x squared, And so what we want to do is we want to first divide by 2. Divide by 2. And so now we're left with x squared equals 49, like that. We're getting very close. And now we want to square root this as shown here. So I square rooted as shown here. And I end up with x equals 7, because we know that the square root of 49 is 7. And now one thing I forgot to mention in the last example was, it's not just 7, it's positive or negative 7. So let me go back and I already put it there, positive or negative 7. No, I'm sorry, this example right here. So it's positive or negative 4. And so this is important because, when you square it, it's going to automatically become a positive number. So the answer could be positive 7 or negative 7. Now, it can be both, or it can only be one or the other. It depends on the context. And this will make more sense when we talk in future videos. Let's move on. Now, we're moving now to example 3. And again, this is not that complicated. It's just taking what we already know and adding it to the context of using the square root property for quadratic equations. So imagine we have the following. C squared plus 12 equals 0. Now this time, what's missing here is the constant here in front of it, essentially. So I guess you could say the constant is 1 if you want, but it's not really there this time. So it's not different, but it's a slightly different approach, if you will. So first, of course, we subtract 12 from both sides because we want to isolate the variable that is raised to the second power, and we get and we get c squared equals negative 12. Now this negative is going to be a problem because I will have to use imaginary numbers. But first, I'm getting a step ahead of myself. Of course, now we want to square root everything like I've just shown you here, and we end up with c equals the square root of negative 12. And like I just mentioned a second ago, oh, by the way, I forgot my plus and minus here, positive or negative. Now, again, like I mentioned before, we have this negative here, so we can't really work with that in the real world. So we're going to use our imaginary unit, and we're going to end up with c equals plus or minus negative 12 with an imaginary unit on the outside. And so now we just factor this. So what two numbers multiplied together will equal 12? And we want to have at least one of those numbers be a perfect square if possible. That's what we want. And so I can tell just from looking at this that if we have c equals positive or negative the square root of 4 times the square root of 3 with the I on the outside, that would be our answer, very close to our answer. And so the final answer, because we can simplify the square root of 4 to just being 2, is c equals positive or negative 2 times the square root of 3i with the imaginary. Remember that the imaginary unit is on the outside of the radical, not on the inside. And so that's our answer for example number 3. All right, here's our last example, and then I will go back and I will review what we did in the prior videos. I'm not videos, but in the prior examples, excuse me. So here's our last one. So this time we have 5r squared minus 2 equals 34. So watch what we do this time. It's the same process. We add 2 to both sides, and we end up with 5r squared equals 36. Not quite done yet. And so now the next thing we have to do is we have to divide both sides by 5, because that's how we're going to get rid of that 5 here. So divide by 5, divide by 5, and we end up with r squared equals 36 over 5. And so, as I said before, we want to square root these, so I just do all this to make it simple. And I end up with r equals the square root of 36 over 5. Not quite done yet. I need to rewrite this, and then I need to rationalize the denominator. So see if you can follow what I do here. So what we do now is we have r equals, and then we have the square root of 36, and then also have the square root of 5. It's the same as the values down here. It's equivalent expression, if you will. Now, we normally do not like to have radicals in the denominator. So the way that we get around this is we will rationalize the denominator. In other words, we will multiply the numerator and the denominator by the denominator. So watch what I do here. And we've done this in prior videos. So multiply this by the square root of 5, multiply this by the square root of 5, like so. And so what happens is that when you have a square root times the square root disappears. And so our final answer here, now watch what happens here, is this. R equals 6 times the square root of 5. And remember, all this time, because I'm getting lazy on this, it should be plus or minus. I'm sorry, plus or minus. Plus or minus. All this is plus or minus. I just got lazy. So, plus or minus the square root of 6 times 5 over 5. Now, why is it 6? Because the square root of 36 is 6, so we simplified it here. And so we still have the square root of 5 left over, so we put that here as this. So this is kind of a radical expression, if you will. And then we have it divided by 5, because remember that when you multiply a square root by a square root, the square root disappears. And so that's kind of how you do this. Now, maybe I moved a little quickly. I'm going to go back and review what I've done in these different examples, and then I will conclude the video. So we started by talking about the square root property, which essentially is where you find out, okay, what number multiplied by itself will give me the number that I'm looking for. And the way to think about it is to like think about a square. And you know, if I have an area of say 36, which is kind of my number right here, what number multiplied by itself will give me 36 because I'm looking for a square. And so, you know, the process here is the factorization and all that, and then you can find the answer could be positive or negative 6. Now, in this example right here, it can only be positive 6 because you can't have a negative number for a length. So that's why I'm saying the positive or negative depends on the context. So let's see here. Now, after we talked a little bit about the square root property, we actually went through some actual examples. So the first thing you want to do when you're trying to solve a quadratic equation using the square root properties, you want to isolate the variable. And so you can see in this example, I subtracted 48, but then I had the x squared. The only way to deal with the x squared was to square root it. That removes that. And so then you're left with the square root of 48. And of course, you have to factor that accordingly so that at least one of the numbers is going to be a perfect square and you can get your final answer. And now, just as a quote, remember that the answer is always positive or negative. Always positive or negative. Sometimes I was careless with that. Now, in this next example, it's the same idea, except over here we have no constants. All right, that's different from example 1. So instead, we had to divide both sides by 2 because again, we want to isolate this x squared. And so then, you know, you follow the steps of square rooting both sides of the equation and you get your answer. In this example right here, again, there's really no constant out front. There is a constant here though, and you just subtract 12 from both sides. It's not that complicated, but what was unique here was the use of the imaginary unit because we ended up with negative 12, so as c will become plus or minus the square root of negative 12. You can't have a negative square root, so we use the imaginary unit I here, keep our plus and minus, then we factor the 12 until we get a perfect square right here, and we end up with our final answer of c equals positive or negative 2 times squared with 3i. Let me move to the last one. And with this last one, what was unique here was that we had to rationalize the denominator. This is something we talked about before, but just to go through all the steps here, we first added 2 to both sides because we're trying to isolate that r squared. And then we divided 5 again for the same purpose. And then of course we square rooted both sides to remove the second power here. And then we end up with r equals plus or minus the square root of 36 over 5. Very close to being done, but we do not want to have this square root in the denominator. So we rationalized this answer by multiplying the top number and the bottom number by the square root of 5, which is the denominator. And we end up with our final answer. Positive or negative 6 times square root of 5 over 5. And now the 6 came from when we square rooted the 36. That's the perfect square for that. And the square root of 5 is just left over from this. And then of course when you multiply 2 square roots like that have the same radicand, if you will, you end up with just a whole real number. So I hope that this video was useful for you and that we didn't move too fast here. We try to keep it simple as much as possible. My name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.